Dear students, I myself, Dr. Bharat Parab, discussing about deriving compound interest formula. Okay, so we go ahead to calculate or to derive compound interest formula. We proceed in this manner. We take simple interest for each year successively. So for this simple interest formula, we see for the simple interest formula is principal P into rate of interest R divided by 100 into number of years. Okay. So we take these letters in the formula, that simple interest equal to P into R upon 100 into N, where P stands for principal, R for rate of interest, and number of years N. Okay. So to understand this clearly, we let us see one example. Go through an example, or see, a sum of rupees 5,000 was kept in a bank at compound interest of 8% for 3 years. See, this is the data given. We have to calculate the compound interest. We find CI. CI stands for compound interest. Okay. So you got this. So looking at the above formula, we have principal P0. Why I am calling this P0 is because that is initial. You will come to know soon that why it should not be only P, or it should be P0. Okay. So P0 equal to 5,000. Rate of interest R is 8. Remember, this is compound interest, and number of years N equal to 3 years. Okay. Initially, let us find out the simple interest. We are trying to find out simple interest each year successively. So simple interest for first year, let us call it as SI1, simple interest 1, because it is for the first year. Okay, is equal to PR upon 100, that is P0 initial into 8 upon 100 into 1. N is 1 because we are calculating only for 1 year. So that comes out to be 5,000 into 8 upon 100 into 1. Because so this is simple interest. Okay. Now the principal amount for the first year, after first year, will be P0 plus simple interest of that year is added to the principal. Okay. So P0 plus simple interest gives you the principal amount for first year. Okay. So we take it, P0 is, substitute P0, it is 5,000, and this is SI1, this is 5,000 into 8 upon 100. Now if we take 5,000 common, you get 5,000 into 1 plus 8 upon 100, that is P1 or principal for the first year. Just to understand this, we will calculate P1, which is here. We have solved this bracket. We are not trying to solve this bracket because we need it as it is to derive the formula. Okay, but just to understand, we have solved it here, and I'm getting P1 equal to 5,000 into 108 upon 100, that is 5400. Naturally this has increased than this because 400 simple interest has been added to the initial amount or initial principal, and then this is the new principal now. Okay, that this is the new principal, we keep it as it is. Okay, and you will come to know why it should be as it is. Okay, let us consider this as P1. The whole thing is P1. Now simple interest for the second year, SI2. This was SI1, this is SI2. Okay, now this is in formula remains same. Here we need to take P1 into 8 upon 100. Okay, so this is the difference. P1, this was P0, this is P1 into 8 upon 100. So principal amount P2, this was for first year. Now for the second year we take it for P2 after 2 years is P1 plus SI2. Got it? Very easy. So P1 you write as P1 only, and SI2 is P1 into 8 upon 100. Now we take P1 common, and you get P1 into 1 plus 8 upon 100. Okay, got it? This P1 into 8 upon 100, same as this. This was P0, now this is P1. Okay, so we go ahead with this. Just remember this. Okay, so we substitute the value of P1 to get P2. This is the value of P1, 5000 into 1 plus 8 upon 100. Okay, and this was there itself. So if you see here, this and this multiplies. So 5000, we go ahead with this at 5000 into 1 plus 8 upon 100 square. Okay, this and this added square. This is for 2 years. We are calculating for P2. There is some connection between these two and these two. Whenever you go for 2 years, you are getting this square. We will see further and try to correlate this. Okay, in the meantime, let us calculate what is actually P2. I have calculated it here for you, that this I have solved it. To derive the formula, we are not supposed to, we are supposed to keep it like this. We are not supposed to solve it because we are trying to derive the formula. But just to see and to understand, I am calculating it. P2, this is principal after 2 years. Okay, 532, that is increased. Okay, because we are adding simple interest to this principal. Initially it was 5000, then it was 5400, now it has become 5832. Okay, at the end of 2 years. And now we will calculate simple interest SI3 for the third year. For this will be principal. Okay, so we go here, SI3 will be P2 into 8 upon 100. Formula remains same, only this is changing, and we are calculating it for each year separately. Okay, so P3 is amount after 3 years is P2, okay, plus interest of the third SI3, interest of the second year. Okay, that is P3. P2 is P3 is P2 plus SI3. So P3 is P2 plus SI3 is this value, P2 plus P2 into 8 upon 100. Okay, got it? This P2 is this, and this SI is this. So we have added this. Now we take P2 common. So P3 equal to P2 into 1 plus 8 upon 100. Okay, so this quantity repeats itself each and every time. Okay, so putting P2, we get, now this P2 value is here. Okay, this is P2 value. So 5000 into 1 plus 8 upon 100, the bracket square, and this quantity is still there. Okay, got it? That means P3 will be 5000 into 1 plus 8 upon 100, and this will add to plus 1, that is 5000 into 1 plus 8 upon 100 raised to 3 or cube. This for 3 years. That is why we have kept it as it is, just to calculate it. Okay, so as here after 2 years it was 2 or square, after 3 years the power was 3. Okay, so getting some connection or relation between these two, we take use of this relation and try to describe the formula. Okay, similarly after n years, amount Pn will be 5000 into this bracket 1 plus 8 upon 100 raised to n. For 2 years this n was 2, for 3 years this n was 3, naturally for n years that will be n. Okay, this is the formula for compound interest. We have derived this formula, and that is for compound interest. Then what is the definition of compound interest? Compound interest is the simple interest was added every year to the principal to calculate new simple interest, and that is called a compound interest. Okay, each time we add some previous year's interest to the previous year's principal, and that was your new principal. Okay, hence we write total amount. Total amount is not only interest, this is total amount. Okay, on calculating by compound interest, it's when you need to calculate by compound interest, you have to use this formula, that is 5000 into 1 plus 8 upon 100 raised to n, this bracket raised to n for n years. Remember, we will be generalizing this formula. This 5000 is not constant for this. We are just to understand we have derived this. Okay, we will discuss about n. What is n years? So n years means time period after which interest is added to the principal. We will discuss something about this after generalizing the formula. So let us generalize the equation first. Okay, and then we will discuss. So we are generalizing the formula here. So total amount by compound interest is equal to this. See, this is for total amount, not only interest. So total amount will be P0 into bracket 1 plus R upon 100 raised to n for n years. Okay, we will discuss about this n at the end of this video. Okay, so P0 is initial principal, R is rate of interest, and n is number of years. Okay, now when to calculate by compound interest, use this formula. Now let us see an example, previous example only. Now let us consider that interest is added after 6 months or half years. Okay, then we will get half interest. That means if P0 is 5000, R is 8%, then simple interest for first year will be 5000 into 8 upon 100. That is for half year we will get half interest. That is for full year we are getting 400. Then 400 divided by 2 will get only 200 rupees. Okay, so we can calculate as simple interest after half year is represented as SI half equal to 5000 into 8 upon 100 into half. Okay, into 1 upon 2. So we take this inside and write the formula as 5000 into 8 upon 200. Okay, 8 upon 200. Then if interest is added quarterly or 1/4 year, 4 times a year, okay, then we will be getting not 400 but only 100. Okay, so this is 5000 into 8 upon 100 into 1 upon 4. Okay, so we take this 4 inside and we get 5000 into 8 upon 400. This is when interest is added quarterly or 4 times a year. Okay, so we generalize this now. So total amount by compound interest is equal to P0 into 1 plus R upon 200 for half year raised to n. N stands for number of half years. Okay, if total numbers are 2 years, the number of half years will be 4. If it is 1.5 year, number of half years will be 3, so n will be 3. Don't take only as years the number of installments. Okay, okay, you got it. Then remember, this is for half year, you change the formula for 200 here, and for quarterly the compound interest will be P0 into 1 plus R upon 400. Okay, raised to n. The n stands for quarters. How many quarters? Okay, so these are the formulas. We have explained what is n also. Okay, use this, try to solve the problems, and try to read the problems, try to think over the problem, and do practice as many problems as you can. This is Dr. Bharat Parab. Need any help? Write to me in the comment section, or refer my other videos on screen on the same topic. I have explained it in different manner. Okay, you can definitely go through it. Okay, thank you.